Good morning, everybody. My name's Henry Bradford. I'm Director of Sales for XtraLight. And with me today is Dana Porter. Dana is our Senior Director of Development. Dana, please say hello to everyone.
Hello, everyone.
Thank you, Dana. And in the background is Richard Every. He's a member of our design team. He's running the technical side of our presentation today. I want to thank you all for making time for us. I know that there are tremendous demands on your time, and we do appreciate it. Before we get to the UVC portion, I would like to just introduce XtraLight at a high level. Our catalog is comprised of our indoor with architectural and commercial products, our outdoor, which is anchored by our Viento site lighting, and our industrial and specialty parts of our catalog. Next, I'd like to begin with a short 30-second video. As you could see in our web address, our URL, XLM, the M for manufacturing. Today, when that term manufacturer has been stretched to essentially include companies that have grown their catalog by reselling someone else's products, at XtraLight, we're manufacturing our products. We have control and accountability. We're a vertically integrated manufacturer, and as our customer, this provides that increased level of comfort to you. The vertical integration of our company provides for us being experts in 5 areas that we've identified that are essential for our products. The first is engineering, testing, manufacturing, quality control, and on-time delivery. I'd like to speak about engineering first. We're experts in engineering. We frequently encounter requests for mod to standard catalog items as well as custom. To define custom, for us, it's a 100% customer design driven product. In addition, lighting layouts, application engineering, how about technical support? You can actually speak with the people who designed and engineered our products. Next would be speed to market. Our in-house engineering provides that reduced time horizon, and I would say our UVC would be an example. We've been working in our engineering department 16 plus months with UVC light sources, and with the emergence of the COVID circumstances, we were able to commercialize numerous products in less than 3 weeks. At XtraLight, our engineering optimizes the characteristics of light for the specific application. One example would be auto dealerships, where uniformity of color temperature and CRI are important, as well as optics, as we are designing, engineering, manufacturing our own optics. We're putting light where you need it, not where you don't, right? No spills, no light pollution. In addition, we understand compliances from your standard safety listings, wet location, high pressure hose down with high pressure temperature, the IP69K, hazardous, even Florida wildlife certified products. So many people today will just put a light source in an enclosure, an amber light source, for example. not at XtraLight. We actually designed the products specifically for that application. Even if you don't have that application within your territory, understanding the engineering behind it provides you with that extra level of confidence in us. Ingress protection, even electromagnetic compliance, EMC, which it sounds pedestrian, it's taken for granted these days. However, with so many products that are not being sold from a manufacturer, this is greatly misunderstood. Process engineering. We are able to apply continuous improvement to our entire catalog. An example would be our SAS and our SPS strip lights, where we just reduced the total installed cost by reducing labor with our new improvements. Next, I'd like to speak about testing. At XtraLight, we own one of only 36 certified nav labs in the entire country. As part of the compliance, we have a separate company, American Testing and Assessment Laboratories. While it's a separate company, it is still physically on site in our location, and you can see a number of photographs of our equipment. We have 5 pieces of equipment. Our first is our goniophotographer. There are 3 classes, A, B, and C. We have a Class C. The Class C provides for both the mirror and the fixture to move and rotate a full 360 degrees. This allows us to capture all angle sets, any distributions with accurate measurements. An example where this is really essential would be if a fixture has unique distributions. You have optics throwing light in specific directions. With our equipment, we can test for specific defined angle sets. Our next piece of equipment is our integrated sphere. While our integrated sphere also measures the luminous output as the goniophotographer, we can generate that quick flash report. We mainly use this for color temperature and CRI. Now, our equipment has a larger spectrum than most equipment. Standard equipment is 400 nanometers to 800 nanometers. We modified and had our equipment recalibrated and recertified for a new spectrum, much larger, 325 nanometers to 1050 nanometers. In addition, our integrated sphere performs the LM82 test for elevated temperatures. As we know, luminous output drops, color temperature rises with the elevated temps. Our next piece of equipment is our walk-in rain chamber. This is going to measure ingress protection, wet location, as well as the IPX9K high pressure, high temperature test. Little known is the fact that ingress protection is actually allowed to be a self-certifying test, not at XtraLight. We're actually testing it on certified equipment. Our next piece of equipment is our settling dust chamber, IP6X. Now, to be in compliance, we're changing our dust every 20 uses. Our last piece of equipment is our thermal in situ testing. Our range is from a -30°C to 100°C. Next, I'd like to speak about manufacturing. We own equipment. We own state-of-the-art equipment. We have 2 Trump 3000 CNC turret punch presses. This allows us to punch up to 3/16 steel. It's almost 8 gauge. We have 7 Cincinnati press brakes up to 8 feet. We have an Amada fiber laser. That's what you see in the photo there. We also have a CNC roller. That's what we use for our ART and our ACR. Next, I'd like to speak about quality control. And if ever there's a word filled with ambiguity, it's quality. What does quality mean to XtraLight? Well, at XtraLight, it begins with our 10-year warranty, bumper to bumper. Next, all shop orders have attached electronic drawings. And we use 100% lot tracking in the factory. Next, 100% first article inspection and 100% every 25th article inspection. And that's not just for the final assembled luminaire. This also is our process, our QC process, for the component parts that we manufacture and go into the final assembled luminaire, end caps, housings. Next, every LED board is 100% in-house single bin. We're not mixing diodes. There's a complete uniformity of color temperature. Why is that important? Well, as LEDs do not fail at once like fluorescent and degrade over time, without single bin, the lack of color temperature uniformity becomes more and more pronounced. We have 100% LED board control from level 1, which is the bare board, to level 2, which is the placement of the LEDs, to level 3, the installed finished product. And lastly, all XtraLight factory employees are W-2. No temp labor in our factory. Why is that important? Well, this is skilled labor. We have an average tenure in our factory of over 13 years. We actually have one production line that has the average tenure over 20 years. So it's really our people that make a difference. Next, I'd like to speak about on-time delivery. What's the worst thing you can see an electrical contractor doing on a job site? Answer, not installing light fixtures. I say that in a bit of a humorous way, but we understand the contractor is working on time. And for us, that commitment we give you is so very important, and we take it so very seriously. We have two metrics that we report regarding our on-time delivery. First, our on-time delivery last month was 97.6%. What restricts us from the 100%, essentially a third-party supplied sensor, for example, or a request from a contractor. Please ship in phases, ship by floor, ship by building. And of course, we're going to always accommodate our customer requests. Next, average lead time. Now, for standard catalog items, 7 to 15 days, we're shipping every standard catalog item. However, last month, our average was 11.1 days. Lastly, our InstaShip program. We have 16 products that ship within 24 hours. What's key here also is no additional expediting fee. It's not a $5 charge per fixture. It's not a $25 charge per fixture. It's part of our standard service. Next, I'd like to share 3 case studies. Our first 2 case studies center around our SHB product, so I'd like to introduce that to begin with. This is our standard linear high bay. It's slim profile, it's versatile, it's lightweight. When I say versatile, 9 lumen packages, 4 color temperatures. We have 4 optic options, one being no optics with a raw lambertion. We have our 90 degree, our 60 degree, as well as our narrow proprietary aisle optic. What's important here is this aisle optic, this was designed and engineered by XtraLight. It's a molded optic, precision formed acrylic, and it's highly repeatable. That's part of our quality control. Options, sensor ready, EM capable, 480 volt, elevated ambient temps, 50C. Some part numbers are DLC listed. Some part numbers are on our InstaShip. Black finishes standard, wire guard standard. Mounting is cable or chain hung and pendant. Now on to our case study. Well, here, the problem was that the light levels above the finished floor were insufficient. We were at 9.2 foot candles, and the customer needed 18. So the first suggestion from a counterparty was increase the lumens. We see your specification sheet. Yes, that was an option. But at XtraLight, we understand energy. So to increase the lumens, we are going to increase the wattage, which is going to increase the energy consumption, which is going to increase the operating expense. Instead, we understood the initial part number, which was a raw Lambertian with no optic. There was light loss at the top of the stack aisles, right? We didn't want to overlight walk aisles. By using our narrow aisle optic, we were able to, and you can see the part numbers, the only difference is the optic, we were able to more than double the foot candles on the workspace without increasing wattage or energy consumption. So this was a big win for us, and the customer was very satisfied. Our second case study, I'm going to ask Dana to share details.
So in this case study, it was similar to the example Henry just talked about, where we were able to use specialized optics to hone the light in where it was needed, and we were able to bank on that extra energy savings or wattage savings to reduce the lumen package, but still hit the light levels we were needing. So in this case, the customer wasn't too worried about electrical savings. Their main problem was that they were having quality control issues, and they thought a large portion of those were caused by poor lighting conditions and quality control supervisors not being able to catch blemishes prior to it leaving the factory. So the competitor in this job, when Major Tool went to them and said, we want our foot candle readings to be 100 plus in most areas, their response was to increase the wattage, which would then increase the lumens, which would then increase foot candles. Our solution was use our optics, hone in that light where it was needed, don't overlight walk aisles or the tops of cranes or the tops of the stack aisles, put the light where it's needed, and we were able to accomplish that with lowering the light levels because we weren't getting all that wasted light. That light was honed in on where it was needed, and we were able to accomplish the customer's goals of increasing the foot candles to 100, and at the same time, still yielding the customer a $250,000 per year energy savings as a secondary benefit to their number one goal of increasing foot candles.
Thank you, Dana. Our third case study is on our Viento product, and this is in a video. Next, I'd like Dana to please introduce the features and benefits and performance specifications of our Viento.
Thank you, Henry. The Viento is our flagship outdoor product. It's very versatile, comes in 3 sizes, a small, medium, and large. That gives you the scalability from 4,000 lumens of output to upwards of 43,000 lumens. It's controls agnostic, 3, 5, 7-pin photocell receptacle, so you can use whatever controls you'd like to conform to. Comes standard in bronze and white, but we also carry housings in raw aluminum, so we can match any RAL or Pantone color. Unique features about this product: it has rotatable optics that allow you to create unique lighting layouts within spaces. It allows you to create lighting layouts less mounting hardware, which saves money for your end users. Rather than using shoulder-to-shoulder mounts or bullhorns, you can mount direct to the pole at 180 degrees and the light will still shine into the lot. There's precision molded optics. They have arrows molded into the optics in order for the installers to be able to install these correctly. So there's no question on how to install these whenever you're ordering them in a left and right orientation on the edge of a lot. The installer would simply install the fixtures with the arrow pointing in the direction that they want the light to go and install it on the pole. Very easy. Toolless entry so that the power supply compartment is easily accessible without any tools. One person install. It has a keyhole slot on the back so you can install the first top bolt first You'll then hang the fixture by that bolt using the keyhole slot, which then frees up your hand to enter the second bolt without having to utilize 2 people. Also, some items available on InstaShip Express. Some are DLC and DLC Premium, all IP rated. These also have a vibration rating, so they are good for bridges, tunnels, things like that, and just allows for a lot of versatility when designing lots.
Thank you, Dana. XtraLight is a manufacturer in Houston, Texas. We are BAA compliant with our catalog, and we appreciate the opportunity to introduce who we are. And now we're going to move to the UV portion of our presentation. We have multiple products, our handheld, our mobile unit, and Dana's going to share those details. So thank you, Dana.
Thank you, Henry. We're going to move into the UVC portion now. We're going to answer a wide range of questions that we commonly hear when doing this presentation, and answer a lot of your questions that you may have about UVC, and talk in detail about the products that we currently offer. So there's 3 types of UV wavelength: UVA, UVB, and UVC. We're going to talk specifically about UVC today. UVC is between the 100 and 280 nanometer range and is medically categorized as germicidal. That's the technology that we use in both of our units, and that's what is used to eliminate mold, viruses, and bacteria. Our units specifically use the 254 nanometer wavelength. We use that wavelength because it's the most effective wavelength and allows for the most efficient disinfection of rooms and spaces using the mobile and handheld unit. As you can see on this graph, UVC is on the far spectrum and outside of the visible light range. When using both of our units, you will see a blue hue. That energy being emitted from the lamps is about 10% of the full energy that is being emitted, and it is not the wavelengths that are actually doing the disinfection. That's actually going to be within the visible light range that you see there on this graph, and the rest of the 90% is over on that, between that 280 and 100 nanometer range, that is actually doing the disinfection. The way that UVC works is it damages the RNA and DNA of microorganisms, which causes them to be inactivated. And the way it does that is it interferes with the DNA and RNA structure, much like pulling pieces out of a Jenga game, and it allows or does not allow DNA or RNA of that microorganism to continue to reproduce or live. These are our 2 units pictured here, both the handheld and the mobile unit, and I have listed here the irradiance values at different distances. The irradiance values are going to be the amount of measurable UV being emitted from the units, and we'll talk about that more in a little more detail. The main thing I want to say here is the effectiveness of UVC increases as processing time increases. So the longer that something is exposed to UV light, the more effective it's going to be at disaffecting that surface. And then the effectiveness decreases as distance from the surface increases. So the farther away an object is from either of these units, the less effective it is and the longer you're going to have to treat it. And that's what these 2 irradiance graphs show here. As you can see, as you go from closer to the units to further from the units, that irradiance significantly decreases, and that's just showing your effectiveness of the units going down as you get further away from the unit. So the handheld unit. The handheld unit is going to be very lightweight, very portable, used for tight areas or areas you may be constrained from getting access with the mobile unit, high touch areas that you want to treat multiple times throughout the day, desktops, credit card kiosks, lobbies, things like that. It's going to be 2 feet long and weigh about 5.5 pounds. Total shipping weight's about 22 pounds, and that's with all the PPE in there and the case that it comes in. It comes with a nice mobile carrying case that has wheels and a handle on it, much like a carry-on baggage when you're traveling. Comes with a 20-foot cord, and both the mobile and the handheld unit are going to operate off a standard 120 volt outlet. So very common, easy to use, and easily acceptable. It's going to have a handle on the back and then also a finger handle, make it easy to hold and have a support for your other hand in case your arm gets tired. But like I said, 5.5 pounds, so pretty lightweight. We use the 54 nanometer lamps in these. This one uses two 2-foot quartz glass lamps. One question we commonly get is, why are we using lamps rather than LEDs, as LEDs are a more advanced technology? One was price. We wanted this to be something that had an ease to market, and LEDs are $15 per diode prior to being placed on an LED board and then being installed into a finished good. So with that, you need a large number of them in order to get the strength of UV light needed for it to be effective. And it would have tripled and maybe even quadrupled the cost of the units if we went that route. Second reason is effectiveness. The UV LED diodes that we have access to are not as effective as these quartz glass UVC lamps. So your treatment times are lower with these lamps than what they would be with LEDs, and time is money. So we wanted something that was the most effective out there and less expensive, more effective. It was almost a no-brainer. The third was lifetime. LEDs and lamps, when it comes to UVC products, have a much lower lifespan than traditional fluorescent or traditional LED. So in that case, you have to replace these lamps about every 9,000 hours or suggested every year. If you were having to make that reinvestment of LEDs yearly to maintain these units, the reinvestment cost would be significant to keep them operational. Using a lamp and ballast system significantly reduced the maintenance cost of these units. And lastly was lead times. We knew that there was going to be a high demand for these, and we wanted to be able to satisfy our customers and keep the XtraLight standard lead times to par as much as possible. And that was just out of the picture with LEDs, as a lot of them had lead times of upwards to 12 weeks or more. So with that, we made the decision to move forward with the 254 nanometer quartz glass lamps. Both of the handheld unit and the mobile unit are going to operate on a 1-for-1 system when it comes to lamps and ballast, meaning for every lamp there is a ballast. And the reason why we did that, in the case that there is a ballast failure, your unit doesn't become unusable. So in the case of this handheld unit, if one ballast fails, you still have one lamp on and it is still usable until that unit can be serviced. The handheld unit is backed by XtraLight's UV warranty that is available online. That contains a standard 10-year warranty on the workmanship of the unit, and then it breaks down the warranty to 1 year for the lamps and ballast and goes into more detail, and you can find it on our website. We'll move into the mobile unit now. Attached here is the mobile unit. It's going to use the same technology as a handheld unit, but in a 4-foot form factor rather than a 2-foot form factor. Each lamp is still going to have the 1-for-1 configuration, so every lamp is going to be paired with a ballast. And same scenario here. You're not going to have half your fixture go out. If you have a failure of a ballast, you'll simply only have one lamp out, and the unit will continue to be able to be used in disinfecting spaces until that machine can be maintained and service can be done to reinstall a new ballast. The height of this is about 5 foot, weighs about 65 pounds. Both the mobile and the handheld unit are going to come with all the PPE you need to operate them out of the box. And they're also going to come with some dosimeter cards, which I'll talk about more in a little bit. Lamps on this one still has the standard 9,000 hours and is still backed by XtraLight's UV warranty. The mobile unit operates at 320 watts and has some unique safety features that I'd like to talk about. The first one's going to be dual power switches. The dual power switches is going to be a unique feature that allows the operator to be intentional about the light being turned on. You're not going to be able to accidentally turn it on. You're going to have to turn on the master power, followed by a secondary power switch. The secondary power switch is going to be Wi-Fi enabled, and it's going to have a timer and an app embedded. What that's going to allow you to do is control the amount of time that you want that unit to be used and set treatment times based on how long you think it's going to take to treat a specific area or based on dimensions and target areas. You can also turn the unit on and off based upon that app, or just check the status to see if it's still on or if the timer has expired and the unit is now off. What that's good for is one that allows a operator to get out of the room before it turns on or turn the unit on once they've exited the room. And also, if they are treating a large space with multiple units, they can place this into a room, start the timer, move on to the next unit in the next room, and be able to monitor the status of each one based on this app. And you can name each one of these units in that app. So you can use an asset number or just randomly number them. However your company would do it, you can monitor the status of multiple of these in that one app. It also has an occupancy sensor that's going to work in reverse fashion. So in lighting, the standard occupancy sensor will turn lights on when motion is detected. This will turn the light off if motion is detected or if sound is detected. It's dual technology, and it allows the unit to be disabled when either of these are detected to protect occupants of the room. Once the unit is turned off, it goes into the time delay that you have set on your timer in your secondary power switch, and it'll continue to make that circuit until no sound or no motion is detected. One question we get a lot is, well, if there's a PA system or something like that, you can disable either side of the occupancy sensor that you'd like. So if you want to disable motion because maybe you have conveyor belts or something in the room that it may be picking up and only go on sound, you can do that. You can completely disable that sensor if needed, or you can also just disable the ultrasonic portion of the sensor. That way PA systems or loud machinery isn't causing your unit to turn off and prolong treatment times. Where can you use UV disinfection systems? You can use them essentially anywhere you have access to a 120 volt receptacle. Locker rooms, schools, transportation, hotels, gyms, spas, retail spaces, restaurants. A commonly asked question is, can you treat food with UVC? A commonly asked question is, can you treat food with UVC? And the answer is yes. You may have some secondary side effects on the produce itself. For example, if you treat some lettuce with UVC, it may cause that lettuce to wilt prematurely or a little bit quicker than what it normally would. That lettuce would still be 100% edible, and you would not have any secondary side effects due to any kind of contaminants. All of our units do not emit ozone, so anytime that our units are used to disinfect a space, they can be reoccupied immediately since there are no secondary contaminants. How do we know UVC disinfection works? You heard me mention earlier that we include dosimeter cards with the purchase of either the handheld or the mobile unit. I have that picture here. This is going to be a key factor in validating that UVC works and that you're getting the correct dosage of UVC while you're creating a treatment plan. So that's going to be your number one way to know disinfection works. And the way this card works is that center that is yellow will turn from yellow to orange when it's exposed to 50 millijoules, and then change from orange to pink once it's been exposed to 100 millijoules. And we'll speak on these cards and the technology a little bit more in another slide. Another way that you'll be able to know UVC disinfection works is a visible reduction in mold. For example, if you have a chair that's been on a patio and you treat it with UVC, you'll see a visible reduction in the mold without using solvents or scrubbing it. Just from the treatment itself, it will begin to inactivate that mold and you will see the reduction. All line of sights and surfaces will become cleaner. You're going to smell it. You're going to be able to smell the odor as it's working, as it's disinfecting, and as it's eliminating pathogens. That's going to give off an odor. And as a secondary benefit to treating spaces with UVC disinfection, it's going to increase your indoor air quality. So there's other technologies out there like the sprays and Clorox, things like that. That's going to treat your surfaces, but it's not going to treat your air, where UVC will also disinfect the air and improve your indoor air quality for employees and clients. Next, we'll talk about how to determine exposure time and the steps to do that. We'll start off with safety, go over some of the basic UV terms. Some of those you've already heard me mention, but I'll just explain them so you can better comprehend the terms that I'm using. We'll identify the different doses of different pathogens, calculate some spaces to kind of show you how those calculations work and how you would then validate your calculations. Well, next we'll talk about safety guidelines. The number one effect that UVC can have on the body is going to be like a sunburn for your skin and harsh eye redness, and irritation. Your eyes are going to be the most sensitive part of the body. You're going to want to always make sure you're wearing those glasses. In intense cases, it can affect your circadian system and your immune system. With our units, with the safety features enabled, and if you're wearing the proper PPE, in no situation should anyone be exposed to that amount of UVC to where they would have that effect. But I just like to mention it as a precaution and kind of show people how important it is to wear the PPE. So like I said, protect your eyes, use that PPE we provide, establish a plan to disinfect, use those timers and safety features that we've put on the unit, and use the hazard warning signs on the doors of spaces, those to be used much like a slippery when wet sign, and just to let people that may be entering the space what's happening. And keep the fixtures in the protective case. Just that's going to protect your lamps. With lamps breaking, that's going to expose people to glass. It's going to expose people to mercury. So you're just going to want to make sure that those lamps are protected. The don'ts are going to be the exact opposite. Don't expose your eyes and skin. Don't allow anyone who's uneducated on the units to operate them. Don't allow anyone to treat an area without the proper PPE or enter an area while it's being treated. And don't touch the UV lamps while they're operating. They do get hot. Next, we'll talk about permissible UVC exposure. Permissible UV exposure is the amount of UVC that somebody can be exposed to within a day that has been categorized as okay. And this was published by ACGIH, and it's the duration of exposure per day in different irradiances that have been published. So I put this on here and just cross-referenced it to our numbers on both the mobile unit and the handheld unit. So we'll use, just say, the 1 minute mark. It's the one at the bottom of the graph. And it says at a radiance of 1, you can be exposed to 1 minute. So when we cross-reference that to our handheld unit, at 10 inches, we're at 0.97. So with that, if you have our handheld unit and you're not wearing the proper PPE, you would only be able to be exposed to the UV light at 10 inches away from that unit for 1 minute before you start having adverse effects. So it's very important to wear that proper PPE. And this is direct exposure. So this isn't through clothes or anything like that. So as long as you're wearing the proper PPE, you're not going to get this exposure, and you won't have to worry about this permissible UV exposure. But for line of sight UV without PPE, this is all your body's allowed to be exposed to in a day. All right, next we'll go under understanding some basic UV terms. Radiant exposure. Radiant exposure is the amount of UV light that something is exposed to or is irradiating out of a unit. And it's expressed in joules or millijoules. Here in the United States, we use millijoules, and it's just a unit of measurement, much like a gallon of milk or 8 ounces of water. And the rest of the world uses joules. The next one we'll talk about is UV intensity. That's going to be these numbers that I have here listed for the mobile unit. That's going to be the intensity of UV light that's coming out of our unit, and it's also measured in millijoules. Exposure time. Exposure time is pretty self-explanatory. It's the amount of time to disinfect a target area. It's the amount of time something was exposed to UV. But the important part of this definition is it's expressed in seconds. So anytime you're doing these calculations I'm going to speak about, they're always going to be in seconds. UVC dose. The UVC dose is going to be the UV intensity multiplied by time. So I'll do a quick example for you. We want to know that if we treat an area for 5 minutes that is within 5 feet of the mobile unit, how many millijoules of UV light would it be exposed to? So like I said, we're always going to express it in seconds. So our time frame is 5 minutes. So we're going to multiply that by 60 so we convert it to seconds, and we get 300. We're going to then multiply it by our UV intensity, and we're going to look at our chart here and see that the 5-foot radius has an intensity of 0.34. So we're going to multiply those 300 seconds by 0.34, and we're going to get 102. So that's going to give us the radiant exposure of UV of anything within that 5-foot range is going to have been exposed to 102 millijoules of UV light. Next, we'll talk about log reduction. Log reduction is just a fancy word or a scientific term for percentage that pathogens are reduced by. So 1 log reduction is 90%, and it goes all the way to a 6 log reduction where it's 99.999, 4 decimal points. So that's the same as like on Clorox bottles where it says reduces viruses by 99.9%. It'd be the same as saying it reduces viruses at a 3 log reduction. Identifying your UV dose. The CDC and World Health Organization both recommend that a target of 50 millijoules is used to deactivate the average bacteria or virus. What I've done here is taken the log reductions from the CDC website and posted some of the most common ones here, just so you could take a look and get an idea of how many millijoules it took to get a 3 log reduction for the average virus or bacteria. And as you can see here, we have hepatitis B, the rotavirus, staph, salmonella, and strep, all of which are reduced at a 3 log reduction or 99.9%, well below that 50 millijoule threshold. I did throw in the adenovirus just to show you what some of the 3 log reductions are on the high end, which was 126 millijoules. However, the average bacteria and the average virus will be reduced at a 3 log at 50 millijoules. So this was designated to answer the question of, does UVC kill the coronavirus? And the answer is yes. So the World Health Organization, or CDC, hasn't published the specific numbers for COVID-19. However, it's a near relative to the SARS and MERS virus, and there's a lot of other coronaviruses that we've experienced in the past that there is a lot of research on. And the coronavirus would respond similarly to these other coronaviruses. So here I have listed quite a few other coronaviruses that are near relative to COVID-19 and what their 1 log reduction exposure would be. And as you can see here, it's less than 1 millijoule of exposure to eliminate that virus by 90%. So it's a very weak virus, very easy to eliminate. You would be able to click on these once this presentation is shared. This is just some reference points that will help you in being able to convince customers that it is a valid technology when it comes to treating the coronavirus. It is a small stranded RNA virus that they would reach approximately or 4 or maybe even 5 log reduction with a UVC dose of about 30 millijoules. So you're treating, your target spaces at 50 millijoules, you're going to get well beyond that recommended 3 log reduction for like viruses. All right, next you're going to survey your area to be disinfected. You're going to measure that space, determine where you're going to place your unit and how far away from your unit is your target areas. You're going to place your dosimeter cards at high touch areas and possibly the places farthest away from the unit. Reason for doing that is if you place dosimeter cards at the farthest unit and it hits 50 millijoules, then spaces in between that would have been exposed to higher numbers. All right, next is calculating your estimated exposure time. So I showed you in a quick calculation on, based on your irradiance and based on your time, how much exposure you get. Now we're going to work that calculation backwards. So if you have your UVC dose that you want to treat an area with, and we're going to, in these examples, we're using 50 since that's what's recommended, and you know your UV intensity out of the unit based upon your radius or size of the room, how to calculate how long you should treat that room for. And it's going to be simply dividing. So we're going to walk through the first row there where it says handheld at 4 inches treatment distance. So we're trying to figure out what our exposure time is going to be at 4 inches away from a target object and how long it's going to take us to hit that 50 millijoules. So you'll cross-reference your distance to the charts that we've provided that show the irradiance of both of our units. And at 4 inches, our irradiance on that handheld unit is 2.8. So we're going to take our target dose of 50 and we're going to divide it by 2.8 because that's what our intensity is. And we're going to get 17.85. And that's going to be your exposure time. One thing to remember is that if that number is anything above 60, you're going to want to divide it again by 60 to get your minutes because it's always going to be in seconds. All right, here's a picture of the dosimeter cards that's showing the different phases of what it's going to look like when it hits 50 millijoules and what it's going to look like when it hits 100 millijoules. These are one-time use cards, and it's recommended that they be read within 24 hours. So once these cards are used, they will not revert back to yellow and they can't be used again. One thing I want to talk about here is our testing of our fixtures. When we test them, it's in a controlled environment and it's a pitch black room. So the reflectance values are 0. There's black floors, black ceiling, and black walls. We're trying to get and measure just the irradiance that's coming out of the units itself and not pick up any type of reflective values that may be coming off the walls or the ceiling. With that, it understates the numbers a little bit when it comes to actual exposure times in ideal situations. And that's what I have listed here. So this is a case study that we did with our units. And here you can see that at 10 feet, it only took 5 minutes to hit 50 millijoules. If you were to use our irradiance values to actually calculate this, it would show your calculated time would be 17 minutes. And the reason for that is because that target area is getting exposed to more UV rays that are bouncing off the walls, workspaces, ceilings, and things like that. So it's almost magnifying the UVC dose that a target object's getting. So we always recommend when creating a treatment plan to use the calculation as an initial treatment time and then use these dosimeter cards to validate that treatment time. And oftentimes your treatment times will be decreased. So you can log that actual treatment time based on the dosimeter card. That way those treatments can be replicated. Just a quick summary. Disinfection of air and surface with UV is a well-established technology. It's a little bit uneasy for people right now because it's in your face and it's new for a lot of people because it's making its way into unorthodox or non-standard applications. Most of the time previously it was used in a lot of healthcare facilities, doctor's office, surgery centers. Now with the lack of solvents and other things aren't readily available, and just for the ease and reassurance of consumers and employees, people are looking for better ways to disinfect spaces. So it's become more in your face now, but it's definitely something that's been proven to be effective and it's been used for a very long time. Like I said previously, we use the 254 nanometer UVC products, and it's the predominant wavelength used today due to its high effectiveness. Always make sure that the operators of these units limit human exposure. And also, one side note, exposure of materials that are subject to photodegradation should be protected. So expensive paintings, maybe organic materials like insulation that could be exposed to UVC can degrade over time. So just make sure you're thinking about that prior to treating a space. How to order. You all have different routes of ordering through, some of you through rep network, some of y'all through distribution. We are always available via our 1-800 number or the customer service line to answer technical questions and things like that. Right now, delivery times are running between 3 and 4 weeks. Handhelds, we can usually get out in 2 weeks, sometimes less. Mobile units are running about 3 to 4 weeks. And depending on the customer type, right now, most orders are prepaid non-cancelable as we are taking orders from non-traditional routes, but that's addressed on a case-by-case basis. I'd like to thank you all for joining us today. We look forward to your phone calls and your emails regarding any further questions you may have on our UVC technology or any of the products that Henry spoke about at the beginning of our presentation.